Hi, good afternoon. I'm Minfan, Linux System Software Engineer at Bytedance. Thank you, Yogesh and Drew, for the introduction. My coworker Neil, who is the leader of the Hyperscaler's system error reporting project at Bytedance, he is at Shanghai right now, and because of COVID, unfortunately, he cannot make it here today. So I will represent him to make the presentation, and I will try my best to answer any potential questions. But you're more than welcome to contact him after the speech. His email will be attached at the end of the slideshow. Yeah, so let's just talk about how we approach this hyperscaler system error reporting at Bytedance, including why and how we design the whole system. Detailed examples will also be shown at the end of the presentation. Yeah, first of all, let's talk about the current error reporting system in industry and have a brief understanding of the background. As we can see from the diagram, there are actually three ways to report SOC errors. The first one, which is the most popular one, is using BIOS or UEFI to enter system management model to collect data from error domain and analyze, and then report errors to BMC or OS for further analysis. Besides the firmware reporting, BMC and OS can also access error domain directly. BMC utilizes the I2C or PCI to access error domain directly and report errors with system event log or black box log, which is an out-of-band solution. Operating system utilize the EDAC or MCE log to realize direct error domain access as well. Most of the companies right now are using BIOS or UEFI to pre-process error domain so that the whole system error reporting can be handled within hardware domain without involving operating system or software. The problem with this mechanism is a system management model, an interrupt or model would affect the system performance. The granularity of error is not small enough either. Meanwhile, once the error reporting fields require updating, BIOS or UEFI upgrading is needed as well, which will affect the system efficiency. In addition, there's a growing need for reliability in like a cloud-first infrastructure. Out-of-band error reporting is getting more popular, but different vendors vary in out-of-band approaches. As Drew mentioned earlier, there's another speech later from a hardware firmware group to talk about BMC out-of-band solution. So let's talk about our solution. As a tech company, Bytedance has the ability to develop our own system, hardware, firmware, and operating system, as well as operation maintenance. System error, which made us wonder if we can utilize our advantage to improve current system drawbacks and design our customized hyperscaler system error reporting with the whole end-to-end data path. So let's move on with approaches we have at Bytedance. First, let's just go through the single system solution of the whole design. As we can see from the leftmost part of the diagram, those are the hardware error resources, which can be managed by different error blocks and then reported to error domain. BIOS or UEFI will be responsible for error domain configuration only in our design instead of error handling, which will offload a lot from firmware and simplify the implementation, as well as upgrading. As you can see here, we use a core boot and a Linux boot to replace a BIOS or UEFI in the previous diagram. This is our Bytedance cloud firmware project. You are more than welcome to check the status of this project as well. Okay, let's just move on. Different from traditional error reporting, both in-band and out-of-band error reporting play big roles in our solution. Out-of-band BMC handles a small amount of data, which is mainly used for operation maintenance. In-band OS handles a massive data quantity as well as details. It's usually used for data analysis and assistant operation maintenance. Just for your information, because the nature of bare metal systems, out-of-band is the only solution for those type of systems. Okay, after the brief introduction of the single system solution, let's move on to how the whole cloud infrastructure works together. As we discussed in the single system case, error resources can be classed into operating system in-band and the BMC out-of-band paths. Those raw data will be collected into online database at a cloud infrastructure. The main component of the system, error decoder, runs offline instead. Yeah, as you can see here, this decoder is actually runs offline. So the benefit of this is it's easier for us to make any upgrading. For example, while including new hardware design or new hardware fault management. Meanwhile, when hardware fails and the whole system corrupts, we can still retrieve data for analysis, even though the quantity won't be as high as online database, but it's still valuable. Eventually, last but not least, we use a flexible interface design in decoder so that once we want to add a new hardware failure, the upgrading won't be painful. Eventually, we also want to achieve platform compatible design. This will need the collaboration from all of you guys, and we're really looking forward to the further cooperation with you all. Here we do want to thank Intel for the great collaborative work in error decoder implementation. After introducing the system design, we would like to share the overall status and the production of our Hyperscaler system error reporting. We proposed the Bytedance HSER project back at 2020. After 2 years of tests and development, Bytedance Hyperscaler system error reporting in-band solution has been up and running on all the systems and already helped us improve CPU error accuracy from 39% to 95%. It also helped us secure known hardware issues quickly so that vendors can have more detailed information for further debugging. Around 20% of the systems have been covered by auto-band error reporting solution, and we're working on implementing more with the auto-band solutions. Our solution has been proved working and is quite efficient and productive, but we also believe without the collaboration of the whole industry, we cannot make it here today. So that we are more than willing to contribute back to the community, share our story, design, as well as the challenges we've made on the way, so that the whole industry can benefit from our experience. We would like to use our project as a start to help building OCP hardware fault management infrastructure requirements. With joint efforts, we can eventually build a more universal raw solution for all platforms. After this speech, Andrew, Yogesh, and Vilas, they will share more on how the community is going to propose BMC based on fault management interfaces and the error analysis tools. Okay, finally, we can talk about some examples of our Hyperscaler system error reporting system. This is a picture of our 1 month in-band data for memory controller for distribution. As you can see, the granularity can be as small as each channel, what have operation, as well as the ratio of the errors. From this example, we can see HSER data can be as detailed as component, IP, operations, and error locating in each IP. With such detailed error data, it's really easy for us to curate existing silicon issues and help vendors for further improvement with clear direction. All right, thank you so much for being here today, and that will be all I want to share. Please don't hesitate if you have any follow-up questions or detail to contact us. We would also like to share our solution and contribute back to OCP as well as collaborative work with OCP hardware firmware group. Thank you so much. Wish you all have a nice day. Do you have any questions?
Yeah, we can take 1 or 2 questions if anyone has it. Then after this, Drew has time for about an hour, so we can eat, we can eat into his time.
Okay.
Any questions?
Yeah, I have a question. The decoder that you spoke of, is that decoder vendor specific, and is that open source, something you can share?
I think we're going to share the interface with them, like a non-disclosure content. We cannot like open yet, but with the interface, we definitely can share it, and we can build like a universal interfaces for different platforms. Yeah, those details we can discuss with the project itself. Yeah. Thank you.
Was the data you showed merged in-band and out-of-band, or was it just the out-of-band part?
Pardon me?
The data that you showed,
Oh, that's just in-band.
That's
Because
just
right now we actually kind of like just focus on the in-band data collection. Yeah.
On this chart, you have a dual path into an OS agent. How are you handling deduplication of the same event?
Pardon me. Is this a
Yeah,
English?
so in the chart, on the bottom left, there's BACD, which reports into the agent and into your database. And then the agent then reports errors back into the database. How do you handle deduplication of events?
Actually, we don't.
Okay.
Yeah.
If you don't mind, I can help you.
Oh, okay.
So BACD is only for certain classes of errors.
You don't talk.
Okay, so BACD is only for certain classes of errors, and they're mutually exclusive today from the other categories.
Okay.
So she's right. They don't have to. I hope you don't mind, but it's okay. They don't have to worry about deduplication because of the way they've implemented it.
Okay.
Yeah. Thank you so much. Yeah. I think that will be all right. Okay. Thank you.
Well, thank